So on question 7, we're asked to multiply several different quantities. And in the case of part A, there's a monomial 3a that we have to multiply by a binomial 2a plus 3b. In B, I'm asked to square a binomial. This is a spot where there could be some problems here, right? Because the answer is not 9x squared plus 1 squared, right? Not 9x squared plus 1. Because we have to multiply that binomial times a binomial. Good practice is to think, if you're not sure exactly what's going on, go ahead and take a moment and just look at a generic area model. So if I was going to square this binomial, I might look at the area model where I'm multiplying 3x plus 1 times itself, 3x plus 1. Now, to find the area of each one of these, right, this is a generic area model. To find the area of anything, I'm going to multiply the dimensions. So if I multiply 3x by 3x, right, 3x times another 3x, I get 9x squared. So this area is 9x squared. To the right of that, I'm multiplying 3x times 1, right? I've got a 3x times a 1 across the top, so this is a 3x. Below, that's where I get the 1 times 1, so this has an area of 1. And then to the left of that, 3x again times 1 is 3x. So you can see what happens here. I've got two terms that are like terms, right? I've got a 3x plus a 3x. Once I know the area of each of the pieces, what I can do then is add those areas together to get this product. So the product, when I multiply 3x plus 1 times 3x plus 1, right, that's when I get 9x squared. And then I have a 3x plus a 3x, which is 6x, so plus 6x's. And then finally, plus the 1. So the result of squaring 3x plus 1 is 9x squared plus 6x, and then plus 1. So the other one that we have that I want to do is this one, because this is it looks a little like, what? How can I do three things at once? Well, do three things at once, not at once, right? If I was to ask you to multiply 2 times 3 times 5, you don't do it all at once, right? I can't even think that way. But I can think, oh, I can certainly multiply these two, right? 2 times 3 is 6. And now that I know that that product is 6, I can take that 6 and multiply it by 5. 6 times 5 is 30, right? So that's what we're going to do here. We're going to just multiply, and it doesn't matter which two, just like it doesn't matter with the arithmetic. I can pick any two of them, multiply them, and once I get that result, I'm going to multiply it by the other binomial. So if I multiply 2x plus 1 times x plus 4, again, I see a binomial times a binomial, so I might use a generic area model. When I do that, across the top, I have the 2x, the 1, and the x and the 4. 2x times x is 2x squared. Below that, I have 2x times 4, which is 8x. To the right of that, I have 4 times 1, which is 4. And then above that, I have x times 1, which is just a plain old x. So I can see so far, right?
Good morning, Shasta High School.
Just a moment. Okay. One of the hazards of recording during the school day. You never know when an announcement's going to come through. So I know that the product of the first two, the multiplication from the first two binomials is 2x squared plus 9x plus a 4. So I've got that product. Now I need to multiply that times the binomial x minus 5. So again, I'm going to use here a generic area model. I've got a trinomial times a binomial. So I'll use a 3 by 2 generic area model. So I'm going to I'll go across this way as my 3 pieces, and then 2 this way. So across the top, I can see that I've got a 2x squared plus a 9x plus the number 4. And then on the left-hand side below that, I've got this x and then minus or plus a negative 5, right? Okay, so those are the 6 pieces that are going to make up this product, and I find the area of each of those individual rectangles, and then I can combine the like terms. So x times 2x squared is 2x to the third. Below that, I have negative 10x squared. To the left and up above, I have an x times a 9x, which is 9x squared. Below that, I have minus 45x. 9 times 5 is 45, so negative 45x. To the right and above, I have 4 times x, which is 4x. And below that, I have negative 5 times negative 4, which is negative 20. So there are a few like terms here. I can see that I'm going to be able to combine these, right? I'm going to be able to combine the 9x squared and the negative 10x squared. Also, I'm going to be able to combine these two, right? I can see the negative 45x and the positive 4x. Everything else is going to stay as it is. So my final product will be, when I multiply these, I can write this up here as my answer, this product will equal 2x to the third power minus a single x squared. Right, that's the result of me combining negative 10x squared and positive 9x squared. So a single negative x squared. Negative 45 plus 4 is going to be a minus 41x. And then finally minus 20. And one of the things I encourage you to do when you're practicing at home is to go ahead and check this with like either in OneNote, it'll do it for you automatically, or you can type this into or use Photomath or something like that, or you can open up Geometry Sketchpad, or not, I'm sorry, GeoGebra, dated myself, open GeoGebra, and in there you can go to the CAS, type it, and it'll do the multiplication. I'm going to check this real quick off camera. Yep, I did check it, and it appears that I was correct. The product is 2x cubed minus x minus 41x minus 20. I don't think any other one of these are particularly difficult, right? If you could do E, clearly we could do C because it's the same thing, right? It's multiplying a binomial times a trinomial. So I would encourage you to do all of those. It's just a practice and then take a look at them. But I did definitely want to record kind of an explanation for E, and I hope you get the point. If you're multiplying three things, just do two of them at a time and then take that and multiply the result.